This is the world's largest wind turbine. It only spins 10 to 20 times per minute. So how does something moving so slowly generate electricity? Let's start with the blades. Their shape isn't random, they're designed like airplane wings. When wind flows across them, pressure differences form. Fast airflow on top creates low pressure, while slower airflow underneath creates higher pressure. That pressure difference produces lift, spinning the blades. The same principle that makes airplanes fly. But here's the challenge. The blade root moves slowly, while the tip slices through the air at nearly supersonic speeds. If the blades had a fixed angle, the stress would snap them like twigs. The solution? Engineers designed them with a twisted, spiral shape and equipped them with smart pitch control. This system continuously adjusts the blade angle, ensuring forces are balanced. When winds exceed 25 meters per second, about a level 9 gale, the system reduces blade exposure, just like a sailboat reefing its sails. At the same time, sensors inside the turbine's nacelle track wind direction and rotate the entire turbine to face the wind head-on. Now, how does it actually make power? The blade's slow rotation isn't enough. That's where the planetary gearbox inside the tower comes in. With a gear ratio of about 1 to 100, 10 to 20 blade rotations per minute become 1,000 to 1,500 generator rotations. Exactly what's needed for electricity. The generator must also match the grid's frequency of 50 Hz. At 1,000 RPM, the generator produces 6 poles of power. At 1,500 RPM, it produces 4, keeping the electricity synchronized with the grid. Today, the largest offshore turbines reach 16 to 18 megawatts. A single rotation of a 16 megawatts turbine generates about 34 kilowatt hours. For an 18 megawatts turbine, one spin produces around 44 kilowatt hours. That's enough to power an average home for a day, with just one turn. But wind is unpredictable. Below 3 meters per second, turbines pause. Above 25, they shut down to protect themselves. Most modern turbines use doubly fed induction or permanent magnet generators. Even if wind speeds fluctuate, converters stabilize the output. Voltage starts around 3,000 volts. Then transformers step it up to 33,000 volts before sending it into the grid. Because all this generates huge amounts of heat. A cooling system keeps the turbine safe, working reliably from minus 30 degrees Celsius to 50 degrees Celsius. At over 150 meters tall, balancing such a giant machine is a feat of engineering. Even tiny imbalances in the blades can cause serious trouble. Maintenance teams must stop the blades, lock the generator, and only then climb up to work. The world's biggest wind turbines are not just machines. They're marvels of engineering, quietly turning the wind into clean energy for millions of homes.